Bismillahirrahmanirrahim. Dear students, so now we are going to perform impact test under the second condition, which is under tension. And for this we have slightly modified the arrangement. Now if I give you a closer look, earlier these two horizontal members were not present on the sides of this hammer because those were not required for bend test, but these members are required for the impact test under tension. In a short while you will see that why do we need these. And here is the specimen that we will be using for impact test under tension, and Dr. Rizwan will help us in installing the specimen. In the hammer we have a hole in which we tight the specimen. So one difference in this experiment, in this performance is that in case of impact test under bending, the specimen was installed in the path of the hammer. This time the specimen is installed on the hammer and its mass is added to the mass of hammer. So we will let you know that how much is the mass of the specimen, and there is another additional component that will be installed on the specimen. So Dr. Rizwan, would you please install that component as well? So it's a kind of small hammer, and why do we need this and how the specimen is subjected to tension, I will explain that to you in a short while. Okay, so you can see that the hammer, this additional component is attached to the hammer, and in one case we will install the hammer, we will place the hammer in this case, in this way. So when the hammer will rotate, this part will go smoothly through these two bars. But when we plan to break the specimen, then we will change the orientation of this component, and then while the hammer will be moving or rotating, this part will collide with these horizontal components, and as a result this specimen will be subjected to tensile load because the hammer will have the tendency to move in the forward direction, and this part will restrict the movement of the specimen, and as a result the specimen will be subjected to tension and it will fail. So our first run of the hammer will be in this orientation, that will be the free run. So let's see what do we get. We will have to set the angle value equal to 0, and now Dr. Rizwan will help us in rotating the hammer. So first we have to rotate the lever in the opposite direction, and then we clamp the hammer, and then we start rotating the hammer in the opposite direction. Alright, this noise shows that the hammer is clamped, and now we have changed the direction of rotation of the lever. We have set the needle equal to 0. The hammer is moving in the upward direction, and we are about to reach the maximum height. Alright, here we go. So this is the free run of the hammer in case of impact test under tension, and let's see how much is the angle value. Okay, the angle value is about, I think, 152. Yes. So the angle value is 152 degrees, and as we discussed in our instructions, that in this case some of the students assume that the angle value should be smaller because the hammer is heavier now, but actually that's not the case. Actually, because if the hammer is heavier, it means that it has higher inertia and it has higher resistance to change its state. That is why with a heavier mass it goes up to a higher elevation. So if you compare this θ1 with the θ1 of impact test under bending, you will see that this θ1 is larger. Now after this free run, our second run will be in the second run we will break the specimen. So we will clamp the hammer again, but this time we will change the orientation of the additional member that is attached to the specimen in such a way that it strikes the additional bars. Okay, the hammer is clamped now, and we have changed the orientation of this additional member, and now when the hammer will rotate, this component will collide these bars, and as a result the specimen here, the specimen will be subjected to tension. Let's see how we can do that. Alright, so we have adjusted the needle to 0 and now we are lifting the hammer up. We have to maintain a safe distance because when the member will fail, it will move away from the machine. Okay, so here we go, and you see the hammer, the additional part, the small hammer, it collided with the bars, and as a result it broke the specimen. Now let's have a closer look. So here is our specimen. I'll wait for a while till the hammer comes to rest, and here is the angle value. So this time angle is about 102 degrees, I would say. So theta 2 for impact test under tension is 102 degrees. This completes the performance of this experiment. The theta values are with you. The mass of this impact test under tension specimen and this additional part, these masses are important for us, so we will let you know how much is this combined mass, because you will need these masses in your calculations. So here is the broken specimen, and you can see that from the center. In fact, for this specimen as well, we have made a groove on the specimen to have a predefined failure point, and here are the two components of our failed specimen. So Dr. Rizwan, how much was the mass of this specimen plus that additional component?
I think 681 grams.
Okay, it was 681 grams. You will need that mass. In the instructions we will explain that how to use this mass. Okay, so with this, performance of this experiment is completed. Thank you very much.